A photo taken from a telescope can show us this big red spot rotating, and that's how we'll start our measurements for how long a day lasts on Jupiter. We can see the red spot at 8:30 universal time on the picture on the left, being fairly to the right, and then 40 minutes later on we can see from this photograph that the spot rotated and approached the center. Dimitris, any questions?
Yes, I think that in the video the red spot was on the southern side. Now it's in the
That's right. That's right.
How is this possible?
Does anyone believe that this gigantic phenomenon moved from one hemisphere to the other, or maybe it could be some other reason? Can we define up and down in the universe? Not really. But if we were observing from the same hemisphere on Earth this red spot, then the telescope would show us the image reversed. In life, we're using cameras. If we want to see objects the proper way, then we have to reverse the reversed image. That's why we see the spot rotating in a different manner and being in a different hemisphere. Having this measurement of 40 minutes, then all we have to calculate is the angle that it rotated during these 40 minutes. To do that, now you can see a schematic representation here. That's how this big red spot rotates on this plane. You can also see the south pole being on top and the northern underneath. To do that, we have to use further maths. An Indian mathematician's maths South is called, and certain software. The software is not so difficult. Students can handle it. And with this software, we can see by the projections of these two places of the spot, A and B, the projections on the radius OK, that a triangle is formulated. This triangle shows us, after calculations, that for 40 minutes this spot rotated 24.08 degrees. As you can see that in the blueprint. So all we have to do now is to think of 360 degrees and find out that for whole rotation 598 minutes were needed. That's about 9.97 hours, about 10 hours. This is one day on planet Jupiter. Compared to ours, as you can see, it's much faster. Why do you think we have a shorter day, so much shorter in Jupiter? Manos?
Maybe because a bigger planet makes more fast.
It moves faster.
Yes.
So we should be expecting a much smaller planet to have a much longer day. Okay. Any idea of how accurate these measurements could be? Just an idea, just a guess. And yours? 90%. 90%. Anybody else? Constantina?
85.
85 to 90. It's actually very close to 100%. It's 99.5% of accuracy. Just a 0.5% of error. Any questions on all these that you've watched? Dimitris?
Yes, about the satellite, I have the same question.
Yeah?
Why did they choose to destroy it? I mean, it could be more useful.
Oh, you mean Galileo's spacecraft?
Yes.
Yeah, that is a shame, and we're celebrating Galileo's anniversary, so it's good that you asked. This spacecraft was sent to make measurements on Jupiter itself, and it was orbiting for 8 years. But if we were to leave this spacecraft there was a great danger to crash on Europa, one of Jupiter's satellites. And as you can imagine, there were few left, in the spacecraft that would contaminate possibly Europa's water. This planet is very important to us since it's our best hope for finding extraterrestrial life. So crashing terrestrial spacecraft on this satellite would make this very dangerous. Contamination was the main factor that made us decide to drop the spacecraft on Jupiter. Dmitry?
Yeah, how could it be dangerous? I mean, this spacecraft was traveling for a long time.
Yeah, throughout space. Oh, you're thinking that...
I think that not a living organization or not even a microbe could survive in such conditions and situations.
Sure, if you're thinking in terms of the existence of germs, most of them would die in space. Nowadays, actually, all spacecrafts are decontaminated before sent to space. But how could you exclude the possibility of having germs locked inside the fuel tank, especially when this spacecraft was sent in 1995 and decontamination was not so strict then? So we had to avoid all these possibilities, and unfortunately this spacecraft doesn't any longer exist. Well, if you're thinking of anything else to ask, Manos?
We saw that Jupiter has many gases in different colors, for instance, white and red and orange, but we see that the big red spot is red. It could be white or brown.
It could be lots of colors. Actually, it wasn't so red in the first 100 years that it was observed. It was pinkish, kind of, before it started becoming brown and red. This has to do with the gases that rotate around the planet and the elements that they are made of. For example, phosphorus is one of those that give this unique reddish brownish color. But if we were about to live for hundreds of years and maybe this red spot would still be there, we could have seen different colors. They change according to temperature and other factors that we are investigating. Dimitris?
Yes, that was exactly what I was going to ask. How we know that 300 years is not a great space of time for the nature. How is it possible that this spot changes so fast color?
It has to do with the consistency of the planet and the speed of rotation. This spot rotates with an average frequency of rotation of 2.5 times the frequency of rotation of Earth. There are plenty of factors changing the consistency of this spot, and we are still sending spacecrafts using telescopes to investigate it. Well, that's all from us. Thank you for listening and staying with us. We can now connect with our observatory at Skinnacus, Crete. Thank you.